Now there's two ways to look at this problem. We're trying to find the constant term in the expansion of this. Now the key thing is to work out what your a is. Now we're going to have a as 2x squared, so there's a. We've got a to the n minus r is going to be key in this, and we're going to look at b, and b is going to be our minus 1 over x, and we're going to look at b to the r. Now there are two ways. The way, if you're not confident with this, is to actually just write out the whole expansion and work out where you get x, no x's at all. So when the x's end up cancelling, because you've got a 1 over x and you're going to get x squared, the powers will end up cancelling. Alternatively, you can use a bit of analysis to save you time and realise when the x's are going to cancel. Now the term is going to be given by this, and you can get the coefficient from the binomial section there. Well, let's just look at the term, because that's the key thing to find out when x, the power of x, is going to be 0. That will give you a constant term. So a is 2x squared, so that's our a, and we're going to do n minus r, and we've got 6, got that to the power of 6, n is 6 minus r. We're going to find out what the r term is when these sort of cancel out. Now your b is minus 1 over x, so we're going to have that times by minus 1 over x to the r. So effectively what we've done here is this is our a term as here, and this is our b term here, and we had n, we had n in this expression here and here. These are all equal, so the n is 6 and that is equal to that. So we've worked out which bits are equal. So let's just simplify what this all gives us. We've got the 2 bit doesn't really count because it's just a coefficient, so what we're going to do is we're going to ignore that for now. We'll come back to that later. So you've got x squared to 6 minus r. Well, if you do power of a power, you times them, so you're going to get 2 times 6 minus r. So we're going to get x times 6 to the power of 2 times 6 minus 2 times r. And we're going to times that. Now the negative here is not going to matter either in terms of our coefficient, so we're going to ignore that as well. So you've got x, 1 over x is x to the minus 1 to the power of r. Now if we simplify all this, we get x to the power of 12 minus 2r times by, now it's x to the minus r. Now we want to find out, we can now simplify this, so we've got this times this, so we're going to add these powers. So this equals x to the 12 minus, you've got minus 2r minus r gives us minus 3r. And we want to know when this power is equal to 0. So when this equals 0. So we can see quite clearly 12 minus 3r will equal 0 when r equals 4. So if r equals 4, we can put that now back into this expression to find out what the coefficient of x is. Now we need to remember we've got the 2 back, we've got the minus back, and we will need the NCR bit as well. So let's put that all in. So we've got n is 6. We found out the r being 4 times by the a term is 2x squared, and we got that all to the power of 6 minus r. 6 minus 4 will be 2 times by the minus 1 over x term, and r is to the 4. Now I'm just going to give myself some more space to carry on working. So 6c4, using our calculator, 6c4 equals 15 times 2 squared is 4. We've got x to the 4. Now if this all works out nicely, the x's should all cancel. Times by minus 1 to the 4 is just going to be 1. X to the 4 over x to the 4. Alright, you're just going to raise, that's effectively 1 over x to the 1, you've got 4, raise that to the power of 4, raise this to the power of 4. So the minus 1 will become positive. And we can see that these cancel. So that just leaves us 15 times 4, which is 60. And that is our constant term in the expansion of all of that.